You have seen the night sky before, not through a telescope, not through a screen, just your eyes, adjusting slowly to the dark, picking out a few steady points of light above your head. You might have noticed one star that does not twinkle quite the same way, one that holds steady, like it knows something the others don't. That might have been a planet. Maybe without realizing it, you were looking at Neptune. But to you, it was just a dot, a quiet blue pinprick in a sky already full of them. Easy to ignore, easy to forget, because from here, everything looks small. You are standing on a planet that feels enormous, oceans that stretch beyond the horizon, mountains that take days to climb, cities that glow so brightly they erase the stars themselves. This feels like scale. This feels like size. But it isn't. Not really. Because the moment you step outside the boundaries of your own world, mentally, visually, scientifically, you begin to see something unsettling, something that changes the way you understand distance and light and existence itself. The James Webb Space Telescope does exactly that. It does not just take pictures, it removes the comfort of familiarity. Recently, it turned its mirror, 6.5 meters wide, floating 1 million kilometers from Earth toward Neptune, a planet we thought we already knew. A planet visited, photographed, mapped. A planet that should not surprise us anymore. And yet, it did. What Webb saw was not the Neptune you remember from textbooks, not the deep blue sphere captured by Voyager 2 in 1989, not the calm, distant giant. What it saw looked like something else, something colder, something almost ghostly. Because Webb does not see the universe the way you do. It sees in infrared. It sees heat. It sees what is hidden beneath the visible surface of things. It strips away color and replaces it with structure. And in doing so, it revealed Neptune as a pale, almost white world, wrapped in thin, glowing clouds. Rings that were once faint and barely visible suddenly appeared sharp and defined, like outlines drawn in light. The planet looked less like a solid place, and more like an echo, a ghost of itself, drifting in the dark. This is where the illusion breaks, because what you think you know about the solar system, about planets, about distance, about scale, is built on images designed for human eyes, images that comfort you, that translate something alien into something familiar. But Webb does not translate, it shows. And what it shows is this: Neptune is not just far away, it is almost unimaginably distant. On average, Neptune orbits the Sun at about 4.5 billion kilometers away. That is 30 times farther from the Sun than Earth is. If Earth were 1 meter from the Sun, Neptune would be 30 meters away, far beyond the walls of your room, beyond your street, somewhere down the block. And yet, even that comparison fails, because light itself, moving faster than anything in the universe, takes over 4 hours just to reach Neptune from the Sun. 4 hours. Sunlight that warms your face right now is fresh, 8 minutes old, but the light touching Neptune left the Sun when your entire morning had not even happened yet. You are always living closer to the present than Neptune is. Think about that. And now imagine trying to see something that far away. Not just detect it, not just confirm it exists, but capture it, in detail, with clarity, with enough precision to reveal rings and storms and structures in its atmosphere. That is what Webb has done. And what it revealed is not just a new image of Neptune, it is a new way of seeing distance itself. Because the further you look, the less real things begin to feel, and the more the universe begins to resemble something silent, something vast, something that does not care if you understand it. And this is only one planet. You start where you are, on Earth, solid ground, air in your lungs, gravity holding you in place. Everything feels immediate, close, understandable. The moon is your first step outward. It looks large in the sky, yet close enough to touch if you stretch your imagination just a little. But in reality, it is about 384,000 kilometers away. If you got into a car and drove toward it at highway speed, without stopping, it would take you over 5 months to arrive. 5 months. And that is the closest object in space. Now step further. The sun. So bright you cannot look at it directly. So powerful it controls everything in your sky. It feels distant, but not unreachable. It is 150 million kilometers away. Light takes 8 minutes to get here. That means every sunrise you see is already in the past. The sun you are looking at has already moved, already changed. You are always watching a delayed version of reality. Now imagine Neptune again. Not 8 minutes away, 4 hours. If the sun suddenly disappeared, an Earth would continue orbiting normally for 8 minutes before anything changed. But Neptune would keep moving as if nothing happened for 4 full hours. It would not know. It would not feel it. That is distance. And yet, even Neptune is still part of the same system as you, still bound to the same star, still, in cosmic terms, very close. The solar system itself stretches far beyond Neptune. The region of icy debris called the Kuiper Belt extends outward, filled with remnants from the formation of planets. Beyond that lies the Oort cloud, a vast spherical shell of icy objects that may extend halfway to the nearest stars. Halfway. And still, all of this, everything from the sun to the edge of the Oort cloud, is just your local neighborhood, a small bubble around one ordinary star. Now step beyond it. The nearest star system, Alpha Centauri, is about 4.37 light-years away. That means light, the fastest thing in existence, takes over 4 years to travel between us. If you tried to fly there with today's fastest spacecraft, it would take tens of thousands of years, longer than recorded human history. You are not built to cross that distance. No one is. And yet, the James Webb Space Telescope looks past it, easily, casually, as if it is nothing more than a foreground distraction. Because Webb is not interested in nearby things. It is built to see the deep universe, to look so far away that it is actually looking back in time. When it observes distant galaxies, it captures light that has been traveling for billions of years, light that left its source before Earth even existed, before the sun existed, before Neptune formed. That means every deep image is not just a picture, it is a fossil. Now bring that back to Neptune, a single planet, 4 hours of light travel away, captured in detail so sharp you can see its rings glowing like thin arcs of frozen light. Those rings were first discovered from Earth in the 1980s, barely detectable. Voyager 2 gave us a closer look, but even then they appeared faint, incomplete. Now, Webb shows them as continuous structures, bright and defined. What changed? Not Neptune. Your eyes. Webb sees in infrared wavelengths, which can penetrate dust and reveal temperature differences. In its view, the cold, dark regions of Neptune's atmosphere fade away, while high-altitude clouds made of methane ice reflect sunlight and glow brightly. The planet becomes inverted. Dark becomes light. Light becomes structure. It is the same world, but it feels different, unfamiliar. And this is the moment where scale stops being just about distance and starts becoming something else. Perspective. Because every time you build a better instrument, every time you look deeper, the universe does not become clearer, it becomes stranger. Here is the gut punch. Neptune is about 49,000 kilometers in diameter. You could fit about 58 Earths inside it. That sounds massive. It is massive. But compared to the Sun, Neptune is small. You could fit over 1,300 Earths inside the Sun. And the Sun itself is just an average star. There are stars so large that if you placed one where the Sun is, its surface would extend past the orbit of Mars. Some even approach the orbit of Jupiter. Your entire planetary system would be inside them. Gone. Now zoom out again. The Milky Way galaxy contains hundreds of billions of stars, each with its own planets, its own systems, its own Neptunes drifting in the dark, and Webb can see galaxies beyond this one. Thousands of them in a single image, each containing billions of stars. Each star separated by distances so vast that even light struggles to cross them in anything less than years. And yet, somehow from a small point in space, orbiting a single star, on a small rocky world, you built something that can see all of this. A mirror, floating in the dark, looking outward, capturing ghosts of planets like Neptune, and light from the beginning of time itself. So here is the question. If a single image of one distant planet can already feel this overwhelming, what happens when you realize that this is just the surface of what Webb is capable of seeing? Now step all the way back, past Neptune, past the outer edges of the solar system, past the thin gravitational boundary where the Sun's influence fades into the wider galaxy. Keep going, past the nearest stars, their faint light stretching across years of emptiness, past nebulae where new stars are born in slow, silent collapse, past clusters of stars bound together like islands in a black ocean. You are no longer looking at places. You are looking at structure. The Milky Way itself becomes visible. A spiral of light, 100,000 light years across. A rotating system of stars, gas, and dust, moving in patterns that take hundreds of millions of years to complete a single turn. And even this is not unique. It is one galaxy among trillions, each separated by distances so large that even entire galaxies appear as small points of light, each moving away from the others as the universe expands, stretching space itself like fabric being pulled apart. There is no center you can point to, no edge you can stand on, just distance, endless, growing distance. And somewhere inside all of this is Neptune, that pale, ghostly sphere captured by the James Webb Space Telescope. A single object orbiting a single star in one galaxy among many. It does not know you are here. It does not know it has been photographed. It drifts in silence, wrapped in thin clouds of frozen methane, its rings circling endlessly in the dark. And yet, you can see it. You can look at an image and understand that what you are seeing is real, that those faint arcs of light are actual structures made of ice and rock, orbiting a world so far away that its sunlight is already hours old by the time it reaches it. This is what changes everything. Not the size, not the distance, the connection. Because for all its scale, for all its indifference, the universe allows itself to be observed, to be measured, to be known, at least in part. You are made of atoms forged in stars that died long before the sun existed. The same processes that shaped Neptune, that built its atmosphere and its rings, are part of the same physical laws that shaped you. There is no separation, only distance. And distance, as Webb shows us, is something that can be crossed, Not physically, not yet, but with light, with mirrors, with understanding. You are standing on a small world, looking out into something that has no obligation to reveal itself. And yet it does, one image at a time, a ghostly Neptune, a faint galaxy, a fragment of light that has traveled longer than your species has existed. All of it arriving here, now, at the exact moment you are able to see it. This does not make you large. It does not make you important in the way you might want. But it does make you something rare, a point in the universe where the universe becomes aware of itself. And that might be the quietest, heaviest truth of all, because in the end, after all the distance, all the silence, all the unimaginable scale, you are the one who is looking,